So unfortunately, the calculations, when they get uploaded back into WebMO from the .out file, they actually don't include the molecular orbital information. Right, so if we go through and I had uploaded my ruthenium calculation right here, and we scroll down, right, we see, the information in regards to the single point energy, right, the dipole moment, and so forth, right. We get the the different steps from the calculation, and then we get our partial charges, but we don't get what the molecular orbital, um, you know, what they look like. So what we have to do in this case right here is we just have to do a quick calculation, right? And this doesn't take long, so we can just run this directly within WebMO. And so we just go and set that up. And so one of the things we can do, right, is that all the way here at the bottom I had set it up. So we have molecular orbitals corrected. So we choose that, and then we make sure that we choose everything exactly the same as we had done before, right? So def2 SVP, def2 TZVP/C, zero charge, multiplicity singlet, right? No unrestricted. Rij cos 32, and then under preview, right, we have to make sure that since we're adding in different basis sets for the ruthenium and the phosphine, and then also the other atoms that are being added in, right, we have to make sure that we just add those in there as well. And so what the easiest way that I'm doing it right now is I just have the input file that I had used for the initial calculation open in a different, on a different screen right now. But I'm just pulling that information out right here. And so you don't want to change any of the coordinates, right? Because we did the geometry optimization. Everything should be in the correct positioning. So all we want to do, right, is just simply pull out the specific basis set information, right? So I'm going to go ahead, submit this now, right? So, you can submit that edited input file. I'll click OK. And so now that should run for me. And so we'll see how it ends up. So we can see right here, right, it only took about like 2 minutes, 33 seconds to go. So now when we click on this and it loads up our molecule, right, we can scroll all the way down, and then now we have our MOs, right? So we can visualize everything that we're looking at. And so, one of the things, to point out is when you're looking at the molecular orbitals, there's, there's going to, as you may have already noticed with a lot of the organic molecules and stuff, right, they're not just simply localized. They get distributed across a bunch of different atoms. So you have to do your best to kind of get an understanding of what it is that you're looking at, right? So in this case right here, it looks like, we're looking at a bit of a interaction that's primarily centered on the D for the HOMO right here, right, the highest occupied molecular orbital. Interacting together with the phosphines, right, that are all within this equatorial plane right here, right, and there's nothing that's happening with that hydrogen, right, because the hydrogen just has a 1s, so it's not going to do anything with, what I would probably signify is probably like the dx squared minus y squared, not dx squared minus y squared, right, this would be like the dxy, I think, or something along those lines, and again, the descriptions of which orbitals are doing what, right, is all dependent on what your frame of reference is. And so, we can kind of go through, right, and we can see right here, okay, right, we're getting, the pi back bonding interaction between the d orbital and the CO here, right, because this is going to be the CO anti-bonding orbital right here, but that's forming the pi bonding interaction between the ruthenium and the carbonyl in this case. And you're getting, a little bit of interaction together with the phosphine there as well, right? We go down again, right? This is now then the other p orbital in that instance, and then going through, right, and just like looking at things, right? So this right here looks like it's a anti-bonding interaction, I would say, but between the ruthenium and the phosphorus right here, but then also, a bonding interaction or so, or maybe anti-bonding. I mean, it looks like there's a node there. Between all of them. And so you can kind of, visualize everything that's kind of going on, just going through the different orbitals and stuff, right? So if we look at the LUMO, right, it looks like this is all primarily anti-bonding. And as expected, I would say too, you're not really going to be expecting, once you start going to the unoccupied orbitals, very many direct interactions that, look like they make sense, right? A lot of that stuff is probably going to end up being fairly ligand based, and so if you've already went through, the the UV vis stuff, right? And you've learned about, metal ligand charge transfer or ligand metal charge transfer, right? Those, you can kind of get a sense of where everything is, right, in terms of the energies too.